Me. All right, let's do this. April 8th. I'm going to try to not get off topic or anything like that at all. So here we go. So today is the 8th, and we are solving quadratic equations. And you might say, well, isn't that what we've been doing? And the answer is yes. I have been hiding some particular types of problems from you for a couple of days. The reason behind that was that I didn't want the fundamental idea of how to factor and solve an equation to get gummed up with other technicalities. And so I feel like at this point, you've probably gotten pretty good, assuming you've been doing your practice assignment. You're pretty good at the whole set it equal to zero, build your shells, make that equal zero, make that equal zero. That's probably pretty in your wheelhouse now. So today there's a couple new ideas. Man, I hope these six, finally I got them in the right order. I hope I nail this for you. But one main idea today is where to put the terms. That becomes an issue. Second main idea is what to do when there's a number in front of x squared. And that's really it. If there's any other little ideas that pop up, then we'll discuss them as they come. So first main idea revolves around a problem like this. If you were to go back and look at every problem on assignment like 47, 48, whatever it is we've been working on for the last couple of days, I kind of lose count. There would be no 5 in front of the x squared. And again, that was on purpose. I wanted that out of the way. I didn't want that to be something that we had to talk about. But starting today, I'm going to start blending these in. And so one of the things we're going to talk about today is how to do this when the leading coefficient, we call that the LC, is not equal to 1. And just in case that's confusing, because I know some people don't like new stuff like that, that's the LC. That's just short, like math nerd way of calling him the leading coefficient. So the coefficients in a polynomial are the numbers in front. The leading one is obviously the one that comes first. So again, all I've asked you to do to this point is x squared plus blah, 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 x squared minus blah, blah, blah. But now that there's a number in front, it has a very kind of minimal effect on how the problem ends. The factoring you should be good at. And the other stuff you should be good at, like step one, set it equal to zero. Done. Step two, look for a GCF. Done. Which puts us to the point when it's like, okay, let's start the problem. And this problem is just a factoring problem like all the others. So I'm going to build my shells. What's going to go in my shells? 5x and a 1x. Very good. So I'm going to have 5x here and a 1x here. This is not a lesson today on factoring. This is old stuff. So if you feel like what's going on, it's this old stuff. You already took a test on this. And then what are the signs going to be? Both negatives. Good. I'm so happy and proud that you guys get that. That makes this a lot easier. And then I just got to go and I got to find numbers that multiply to make 21. 7 and 3 are indeed the ones we want. 21 and 1 could be candidates, but they will not work. And what we want to do is go big brain mode, and we want to put the 7 over here. Why? What does that do? It buffs it, right? So by putting the 7 over here, like polar opposite across from the 5, I buffed it up into a 35 or down to a negative 35. And why would I do that? Well, because I want to get close to negative 38. And this works just fine. So, like I said, not a lesson on factoring today. That should be something you're pretty comfortable with at this point. So what we've been discussing in this class is not so much just the act of factoring, but rather, okay, fine, I factored. What are the solutions? And listen, if I talk about red egg, I have no doubt, 100% confidence in this class that every one of you knows that that means that x has to equal positive 7. Again, it's all you've been doing for like 2 days. The new guy today is the green egg. And the question is, what makes the green egg equal 0? What did you say? Yeah, that's the right answer. I'm going to show you something that will solve a couple of problems. It's going to answer two questions. First off, it's going to answer the question of how in the world did that dude get 3/5? And it's going to also solve the problem of what's going to happen when I forget how to do what you just showed me. There's obviously a really short way to do this, by the way. But if that's the only way I show you and then you forget, then you're powerless when you forget. So what I want to show you is this. We look at the green egg up there and we say, I need that green egg to equal zero. And in math, as we become more empowered in math, we understand that anything we want to happen, we can make happen with an equal sign. You want something to equal five, write it down, set it equal to five. You want something to equal -2, write it down, set it equal to -2. Well, I look at this and I say, I want the green egg to equal zero. So what I'm going to do, and this, again, this is something I expect you to do every time. This is just if you forget, I'm going to write 5x minus 3, and I'm going to say, hey, I need you to equal zero. We don't usually do this much work because it's, stuff we do in our heads. But in this case, examine that green equation and just watch us solve it. What do we do first? We add 3 to both sides. Like we remember this. We've been doing this all year. And then what do we do second? We divide by 5. And if you divide both sides by 5, you get x equals 3/5. I don't expect you to do that every time. I expect that to be your backup plan so that someday when you forget what you're doing and you're like, oh, I don't remember how to find the answers when there's an extra number in there, just take it off to the side, set it equal to zero, solve it. And you can never ever say, I forgot how to do it because you can reteach yourself over and over and over again. Good. So let's talk about maybe how in the world did Owen or anyone else, how would we get this quickly? Well, here's the trick. If you're taking good notes right now, which I hope you are, take your finger and do what my yellow pen is about to do. Cover up the 5. Because you would agree that the 5 is why we're having this conversation, right? If that 5 weren't there, forget he's there, and you just got your finger over the 5. If all you could see was x minus 3, what would the answer be? X equals what? X equals 3. And then all you got to do is take your finger off and divide by what's under your finger. Got it? I mean, that's kind of a cheesy way to do it, but that's a quick way to do it, right? And obviously, you don't need to put your finger down. I'm just saying, like, you got to remember that that's like the afterthought guy. So the normal number is there, and then you divide by whatever's attached to the x. Got it? So that's one of a couple new concepts for the day is how do I find my solutions for my factors when there's a number attached to the x? And it's really not that much. Just divide. Switch signs and then set up a division problem. And I will say this, that if whoever, I don't know who said that, was that you? You're totally right when you say that. And I like that when kids start to like come up with their own little like sayings, like little verbal flow charts to walk us through problems. I will just caution you that a mistake I see quite a bit with the green egg, trust me on this one, is I see a lot of people put x equals 5/3. So just remember that if you're going to say something silly like that, that you got to go off to the side and keep reminding yourself that it's the 3 that I move to the other side and then the 5 that I divide by, not the other way around. Right? Make sense? Okay. So every example should not take that long. That's a new concept, and I want to make sure you understand what to do when there's a number stuck to the x. Here's our next one. And this one's going to be pretty much cut from the same chunk of cloth as the last one. And then with the last handful of examples, I'm going to try to just teach you a new sort of idea with every single one. Right. Second verse, same as the first. Why is this problem significantly more poopy than the other one?
Numbers are bigger.
Yeah, bigger numbers aren't necessarily always it, but there's 2 templates, right? That's really what's going to get us is the 10 in the front should be the one thing that makes us feel some burn here. So like the last one, I knew that it had to be a 5x and a 1x, like end of conversation. This one can be 10x and 1x, or it can be a 5x and a 2x. And again, because this is not a lesson on factoring, I feel like that's kind of old news. You guys get all that. So we do know this. What are the signs? One of each for sure. The 40 in the back is all I need to know. If homie in the back is a negative, then I'm like done. One of each. Okay. And now it's just a matter of toying around. And again, I don't want today to be all about lengthy factoring conversations. So I do want to just kind of get right to it. Anyone see it? Where? Bottom one, 3 and 2. Top one, 3 and 2. Yeah, I really don't care. I don't think that's it, is it? What am I doing with a 3 and a 2? Goodness gracious. What I meant to say was I think it's 8 here and 5 here. That's not going to work, but it's kind of what we want, right? Have you done the math ahead of me yet? Yeah, the signs are what are going to get us here. If you look at the ones on the outside, what do they make? Negative 25, and then the ones on the inside make positive 16. And what's negative 25 plus 16? Rats, negative 9, but we wanted positive 9. So this has happened to you. I'm sure it happened to you on the test where you just realize I've got everyone where they need to be. I just need to switch my signs. So again, not intended to be a lesson on factoring. So let's assume that everyone in this room can make it that far. Some of us would get there in 12 seconds. Some of us, it might take a couple minutes, but we get there and woof, there are our factors. So let's see if you learned. What answer comes out of the red egg? Oop. And there it is. And that's right there how quick it happens. So it's 8 divided by 5. No, simplifying it is 8. It's done. It's simplified. Yeah, what you're asking is, do you want me to convert it to a mixed number? No, I have absolutely no desires for you to convert it. Simplifying is enough. 8/5 is perfect. If there was a reason that I wanted a decimal value, like if we were approximating the length amount of time it takes for a rocket to reach a height of something, which we will do someday, then I would like 1.6 seconds. Like that would make more sense to me. But just purely mathematical, 8/5 is gorgeous. Okay. How about the green egg? What do we get? X equals, it's not 5/2. It's negative 5/2. So don't forget, change the sign. That's always a non-negotiable. And then do your division problem. Just make sure you do your division problem in the right order. And if you're not sure what order, just take it off to the side, set it equal to 0, let yourself solve it. Can't go wrong. Okay. Next one. I am going to go against my own note card and write this down a different way. I just called an immediate quick audible on myself here because this one might mess with you. So you've been warned. What would be your first thought? Adding 19x is exactly what I would expect you guys to say, even though it's not correct. Now, here's the deal. You guys say things because you're good students and you're such amazing listeners that you say things that should be correct. And then I throw a curveball at you, and I'm actually going to tell you that this is what you're supposed to do. We're going to move the 2x squared and the 24 over there. And listen, I doubt that you could come up with many logical reasons why that's a good idea. There's only one reason to make what positive? The red one. I hope you're still listening. I'm not done. I've got probably 7 or 8 minutes left, so stay with me. Are you ready to hear this? Listen, you never want the x squared to be negative. And I set this problem up. I called a quick audible on myself because what I've done with you to this point is I've always had you move everything to the left, right? And I got to get us out of that habit today. I got to make us start thinking like, hey, it's not about the left or the right. It's about, I'm going to put all the stuff on whatever side the red term is positive. Do you understand? The quicker route here would be, man, I sure wish I could just move the 19x over. The problem is then I saddle myself with a bit of a predicament. And you can factor with negatives, but it sucks. So what you're going to learn here today is move wherever you have to. Right, left, it's all irrelevant. It doesn't matter. So we're going to pick up the 2x squared and we're going to move it over to the right-hand side and we're going to rename it as positive 2x squared. Is the 19x going to move? Then he's just going to stay as a minus 19x. Okay. But the 24 did have to move and becomes a plus 24. I wish I'd had this conversation with the third hour and fourth hour. I should have busted this out earlier in the lesson, but here's the deal. If Kai wants to put his equals 0 like this, he can do that. Left and right is irrelevant because saying that and saying this are identical statements, right? So you just have to decide, like, which do you like? I personally don't really give a rip, so I'm just going to leave it like this, just so it makes maybe more sense. Like, we moved it to the right, so to speak. So, do you have any questions about what I just said? We will always move the terms to whatever side will cause the x squared to be positive. Everyone else will follow along like little puppy dogs. Doesn't matter. All right, let's factor real quick. So nice news here. Good news is that 2 is a prime. So we have only one template, and it's the 2x and the 1x. And what are the signs? both negatives. And we want an 8, but we want to strategically put the 8 across from the 2 like this to power buff it up to a 16. And then the remaining 3 will go here, and then we're perfectly going to get a negative 19. Right. Good. What are the answers real quick? What comes from red egg? Yeah. Noise, 3/2, 3 seconds, 3 tooths, 3 halves. What comes from the green egg? Good job. Okay, guys, that's let's keep going. Ready for the next one? Can I scroll? Okay. Next one, we're going to have negative 68n minus 24 equals negative 7n minus 8n squared. You should already have a plan of attack. You should already have your side picked out. You should already know, are we moving everyone to the left or are we moving everyone to the right? The answer is left. And then when someone says, why, you don't say, well, because I like the left side. That's Bush League. You don't say that. You say, I'm moving to the left because 8n squared needs to be a positive, and that's where he's going to be a positive. So we're transporting red guy to the west, and we're transporting purple guy to the west. Red guy's leading the way, purple guy's just to tag along. So what will my left side start with? Positive 8n squared minus 61n minus 24. If you're the kind of person that would have put 75n minus 75n, then you're someone who just needs to keep showing work. Okay. Because like if you saw the minus 68n on the left and the minus 7n on the right, you're like, boom, negative 75, suckers. Then no, that's just bad. It's like you're still in need of seeing that addition on both sides or whatever you need to do. So anyhow, here we made it. And this is a double template problem. So we know to set it up as 8n single n or 4n double n. And what are the signs? One of each. This one, I would not have asked this question to you when we started factoring 2 weeks ago. You weren't ready to hear this question, but now you've done so many dozens and dozens of these that I can ask this. There is a smart play right now that does not involve guessing. What is it? Say again? This number right here should be screaming at you. 61's like, can you please look at me? I'm really close to 64. And then you might say something like, well, why do I care? And then you say, wait a second, using the numbers that I have at my disposal, if I think hard about this, if I put an 8 right here, I'm like, boom, thanks for the hint, man. 61 gave me a hint and said, go sound close to me. And then I was like, well, if I put an 8 polar across from that other 8, I got a negative 64. And then I'm like, that's pretty close. So again, factoring should feel less guess and checky to you than it did weeks ago because we start to see things like that 8-8 buff relationship. And then you'd put a 3 here, and then you make negative 64 plus 3. Boom, jackpot. Got it. If factoring still feels to you like you're just throwing darts in the dark, it'll come. Just practice, okay? Eventually, you'll start to see shortcuts. Anyways, what are the solutions that we get? What's red egg answer? Negative 3/8. And what is green egg answer? Good. For these last couple of examples, these did not make it onto my note card last night. I've added these 2 problems because of the questions I've gotten throughout the day. So you're getting a couple of bonus problems. And again, it's because eventually someone's probably going to ask a question about something like this. So let's just get it out of the way right now. So bonus notes problem number 1 is right here. What is that? Yeah. I feel bad as a teacher. When kids do certain things, I feel bad. I saw someone earlier try to pull an M out of this. And I was like, "Oh, I can't fail in this kid. Like, just because there's 2 terms doesn't mean you pull out the M. Like, yes, this one's missing a term, but it's not the back term, it's the middle term. And your job as a student is to look at this and just say, I know that. You're a difference of squares. And I know that to factor a difference of squares, I'm just going to build my shells. I'm going to stick a plus in one and a minus in the other. Not even up for debate. That's how the magic happens. And then I'm going to answer some real basic questions. Here it goes. What's the square root of M squared? So you stick an M there and you stick an M there. What's the square root of 144? Stick a 12 there, stick a 12 there. Being good at factoring difference of squares is a pretty awesome skill as far as your high school success and your college success in mathematics is concerned. What are then my solutions? M equals negative 12 and M equals positive 12. And we might as well use this awesome little symbol because we get a chance to. M equals positive or negative 12. And then this last problem never would have made the cut until a young lady, I won't use names because I'm recording, but during fourth hour asked a question and I was like, snap, I didn't know this was going to happen. So here it goes. Let's just cross this bridge. It's not hard. So this is another bonus problem that is added on in the hopes that it will answer a question sort of preemptively for you. When you get to number, I think it's 9 on your homework assignment, you'll see. Mhm. So let's just think fundamentals first. Do we want to move all of our stuff to the left or the right? Left. 6W squared's like, I am positive, do not move me. Everyone, all you other suckers, come to me. So we will have 6W squared like this. How many W's will we have? 5. Good job. Thank you for not saying 9. And what will our constant be? Nothing. And this one slipped past me when I was proofing the assignment. I just honestly didn't even, I think I was distracted by college basketball or something like that. Not proud of that, but um, no, no. What kind of quadratic is this? It's a GCF, right? And again, to the casual observer, they might walk in and say, well, this is just like the one you just did. Like this one has 2 terms. This one has 2 terms. It's just a matter of which term is missing, right? In the last one that we just did, the middle term was the one that was missing. That's why we were able to factor it in that cool shortcutty way. How we attack a quadratic that's missing its back term is completely different. This time, the missing term isn't in the middle, but rather it's right here. We just learned this, I think, yesterday. I think it was yesterday. Maybe it was Thursday. I don't know. But when you get a quadratic like this that's missing the back term, what do? You pull out the W because it's what they have in common. And it's sure shooting not a difference of squares. So I'm going to take the W and I'm going to say, I'm going to pull a W out of that term and I'm going to pull a W out of that term and put the W out front. And what does that leave us with? 6W plus 5. And then at this point, you've done enough of this to recognize that I almost couldn't trick you at this point in time. I'm asking you a very simple question. How can I make the yellow factor equal 0? 0. I mean, it's this the question that never stops being asked is how can I make things equal 0? Welcome to the rest of your math life. Making zeros is huge. How can I make this equal 0? How can I make this equal 0? It's not 5/6. It's negative 5/6.
I knew the numbers.
So that I think concludes my lesson. Got through it without any major things. I'll leave this going. If you guys have problems you want to go over, I'll just add them on to the end of the recording here for you. Okay.